How was our Earth born? Was it forged in a furnace of fire, or shaped silently in the cold darkness of space? Throughout history, scientists have explored two powerful schools of thought, the hot origin and the cold origin of our planet. According to the hot origin school, Earth and the solar system emerged from matter that was either initially scorching hot, or became intensely heated during its birth. In contrast, the cold origin school argues that Earth was formed from matter that was cold, perhaps always cold, slowly assembling in the quiet vastness of space. Each theory is grounded in science, supported by evolving evidence, and challenged by new discoveries. In this journey, we explore these concepts, their logic, their limitations, and their legacy, in the story of how Earth came to be. But temperature isn't the only way scientists classify Earth's origins. Another lens focuses on the number of celestial bodies involved in the creation of our solar system. First, we have the monistic concepts. These theories involve just one heavenly body. They propose that the Sun alone played the central role in forming the planets, including Earth. The famous Nebula hypothesis is a prime example. Second, the dualistic concepts. These theories involve the dramatic interaction between two celestial bodies, typically our Sun and the passing star. The tidal hypothesis of James Jeans is one of the most well-known ideas in this group. And third, the more complex binary star or trihybrid concepts. These involve more than two bodies, such as a binary star system interacting with another mass. These models attempt to solve the limitations of earlier theories by including more dynamic, multi-body interactions. These categories not only help us organize scientific thought but also highlight the vast complexity of cosmic creation, where stars, dust, gravity, and time all come together to shape the world we call home. Let's start our journey. Gaseous hypothesis of Kant. Immanuel Kant, the German philosopher, presented his treatise entitled The General Natural History and Theory of the Heaven, or the Essay on the Working and Mechanical Origin of the Entire Universe on the basis of Newtonian laws in 1755. Kant claimed that his gaseous hypothesis of the origin of the Earth was based on the sound principles of Newton's laws of gravitation and rotatory motion. In the beginning, his hypothesis acclaimed worldwide appreciation, but later on it was disproved as it was based on erroneous concepts and wrong application of Newtonian laws of gravitation. In spite of severe criticism, the hypothesis was considered a great step forward in the field of cosmogony, and he almost reverberated the mid-18th century with his words, "Give me matter and I will build a world out of it." Kant postulated his gaseous hypothesis of the origin of the Earth on the basis of a few assumptions. He assumed that supernaturally created primordial hard matter was scattered in the universe. In fact, according to Kant, there was a primeval, slowly rotating cloud of gas, now called a nebula, and matter comprised of very cold, solid and motionless particles. In terms of modern scientific language, it can be said, but not described by Kant, that the temperature of primordial matter was near about 273 degrees Celsius or absolute zero or 0 degrees K. This was the reason that cold matter was initially motionless, according to the molecular theory of matter. He further assumed that the particles began to collide against each other under their mutual gravitational attractions. This mutual attraction and collision between the particles generated random motion in the primordial matter. Collision of the particles also generated friction, which generated heat, with the result the temperature of the primordial matter started rising. He further argued that the random motion of the particles also generated rotatory motion in the primordial matter. Thus, the original cold and motionless cloud of matter became in due course a vast hot nebula and started spinning, rotating, around its axis. According to Kant, with the increase in temperature, the random motion as well as the rate of collision among the particles also increased. This gave extra impetus of the rate of rotatory motion, spinning, of the primordial matter. The rise in temperature also changed the state of primordial matter from solid to gaseous particles. Thus, the initial primordial matter gradually changed in hot rotating nebula. With continuous rise in temperature and rate of rotatory motion, the nebula started expanding in size. According to Immanuel Kant, as the heat increased, the size of nebula increased, and as the size of nebula increased, the angular velocity or rotatory speed further increased. Due to continuous increase in the size of nebula, the rotatory speed became so fast that the centrifugal force, away from the center, exceeded the attractional or centripetal force, directed towards the center. The nebula started spinning so rapidly that an irregular ring was separated from the middle part of the nebula and was ultimately thrown off due to centrifugal force. By the repetition of the same process, a system of concentric rings, 9, were separated from the nebula. The residual central mass of the nebula remained as the Sun. The irregularity of the rings caused the development of the cores, knots, for the formation of the corresponding planets. In other words, all the matters of each ring were aggregated at a point to form a core or a knot, which ultimately grew as a planet in due course of time. Thus, it is apparent that according to Kant, the Earth was formed due to aggregation of all the matter of the ring, which was separated from the nebula due to centrifugal force. By the repetition of same process, rings were separated from the newly formed planets, and the materials of each ring were condensed to form satellites of the concerned planets. Thus, the whole solar system comprised of the Sun, residual part of the rotating nebula, 9 planets and their satellites were formed. Evaluation. Though Immanuel Kant based his gaseous hypothesis on scientific principles, Newton's law of gravitation, to solve the problem of the origin of the solar system and the Earth, but his hypothesis has been rendered baseless because it is based on several erroneous facts of science. In fact, Kant's hypothesis was declared dynamically unsound. 1. It was one of the basic assumptions of Kant's hypothesis that there was primordial matter in the universe, but he never explained the source of the origin of the primordial matter. 2. Kant did not explain the source of energy to cause random motion of the particles of the primordial matter, which were cold and motionless in the initial stage. According to Newton's first law of motion, a body remains at rest, or if in motion it remains in uniform motion with constant speed, unless or until an external force is applied on it. The particles of the primordial matter, as assumed by Kant, were at rest and no external force was applied on them. Then what was the cause for the random motion among the particles of primordial matter? 3. The collision among the particles of the primordial matter can never generate rotatory motion in it. It is an erroneous statement of mechanism. 4. Kant's assumption that the rotatory speed of the nebula increased with the increase of its size was against the law of conservation of angular momentum. According to the law of conservation of angular momentum, the total angular momentum of an isolated system remains constant. It means that if any body is rotating, the total amount of its angular momentum will always remain constant unless an external force is applied on the rotating body. Let us understand angular momentum. Angular momentum is the product of the mass, angular velocity, and the square of the radius of the rotating body. No one can change the mass of the rotating body, that is why it is constant. Angular momentum of any rotating body can never be changed unless an external force is applied. Thus, the above equation can also be expressed in the following manner: angular velocity or 1, radius, or size. The second equation shows that there is an inverse relation between angular velocity or the speed of rotatory motion and the radius or the size of the rotatory body. If the radius of any rotating, spinning, nebula increases, or if the nebula expands in size, the angular velocity or the velocity of the rotation of the nebula will decrease. Kant's hypothesis envisages that as the heat increased, the size of the nebula, or radius of the nebula, increased, and as the size of the nebula increased, the angular velocity or the rotatory speed further increased. This statement is erroneous as it is against the law of conservation of angular momentum. Thus, the very foundation on which Kant's hypothesis was based is proved unsound and wrong. However, the importance of Kant's hypothesis lies in the fact that it was first scientific attempt for the explanation of the origin of the Earth. In fact, Kant's hypothesis paved the way for the postulation of nebula hypothesis by Laplace. Nebula hypothesis of Laplace. French mathematician Laplace propounded his nebula hypothesis in the year 1796. He elaborated his concepts about the origin of the solar system and the Earth in his book entitled Exposition of the World System. Laplace's nebula hypothesis was in some way similar to the gaseous hypothesis of Kant. It appears that Laplace's hypothesis is just the modified version of Kant's hypothesis. It may be pointed out that Laplace propounded his hypothesis without mathematical formulation. In fact, Laplace postulated his hypothesis after removing the inherent weak points and erroneous concepts of Kant's hypothesis, which suffered from three basic defects, e.g., 1. Large amount of heat cannot be generated due to the collision of cold particles of primordial matter. 2. Mutual collision of particles cannot generate motion in the primordial matter, and the random motion of the particles cannot generate circular motion, rotatory motion, in the primordial matter. 3. The angular velocity of rotatory speed of the nebula cannot increase due to increase in the size of the nebula. In order to remove the aforesaid defects, Laplace assumed certain axioms for the postulation of his nebula hypothesis to solve the riddle of the origin of the Earth. 1. He assumed that there was a huge and hot gaseous nebula in the space. Thus, he solved the problem of heat of the nebula through this assumption. 2. From the very beginning, huge and hot nebula was rotating, spinning, on its axis. 3. The nebula was continuously cooling due to loss of heat from its outer surface through the process of radiation, and thus it was continuously reducing in size due to contraction on cooling. Based on aforesaid assumptions, Laplace maintained that there was a hot and rotating huge gaseous nebula in the space. There was gradual loss of heat from the outer surface of the nebula through radiation due to circular motion or rotation of the nebula. Thus, gradual loss of heat resulted into the cooling of the outer surface of the nebula. Gradual cooling caused gradual contraction in the size of the nebula. These processes, e.g. gradual cooling and contraction, resulted into continuous decrease in the size and volume of the nebula. Thus, reduction in the size and volume of the nebula increased the circular velocity, rotatory motion, of the nebula. As the size of the nebula continued to decrease, the velocity of rotatory motion continued to increase. Thus, the nebula started spinning at very fast speed, and consequently the centrifugal force became so great that it exceeded the centripetal force. When this stage was reached, the materials at the equator of the nebula became weightless. Consequently, the outer layer was condensed due to excessive cooling, and so it could not rotate with the still cooling and contracting central nucleus of the nebula, and thus the outer ring, layer, was separated from the remaining part of the nebula. This separated ring of materials started moving around the nebula. It is to be remembered that according to Laplace, only one ring of material was separated from the nebula and not 9 rings as conceived by Immanuel Kant. Laplace further maintained that the original ring was divided into 9 rings and each ring moved away from the other ring. All the materials of each ring condensed at a point or not in the form of hot gaseous agglomeration. Each such agglomeration was later on cooled and condensed to form planet. Thus, 9 planets were formed from 9 rings, and the remaining central nucleus of the nebula became the Sun. Satellites were formed from the planets due to repetition of the aforesaid processes and mechanism. This simple hypothesis offered an explanation of the facts that, with a few exceptions among the satellites, each celestial body possesses acquired motions of rotation and evolution in one and the same sense, and that the several planetary orbits are nearly in the same plane. S. W. Wooldridge and R. S. Morgan. 1959. French scientist Roche suggested modification in the nebula hypothesis of Laplace during mid-19th century. He opined that 9 rings were separated from the nebula itself, and these rings were condensed to form 9 planets. Evaluations. The nebula hypothesis of Laplace commanded continued great respect for more than 150 years due to its simplicity, but as the knowledge about the universe and its related phenomena, as well as the knowledge of science and technology of the modern world, increased, the nebula hypothesis began to fade away due to severe criticisms of the hypothesis by the scientists on various grounds. It is significant to point out that the nebula hypothesis not only tried to explain and solve the problems of the origin of the Earth, but it also described the constitution of the Earth. According to this hypothesis, the planets and also the Earth were initially in gaseous state. The Earth was changed into liquid state on cooling, and ultimately the solid crust was formed. But some scientists claimed that the Earth retained a solid condition throughout its period of growth. However, the nebula hypothesis is rendered untenable on the basis of the following demerits. 1. Laplace assumed that initially there was a hot and rotating nebula, but he did not describe the source of the organ of the nebula. Where did heat and motion in that nebula come from? He did not offer any explanation. 2. What was the reason behind the formation of certain fixed number of planets from the irregular ring? Why did only 9 rings come out from the irregular ring detached from the nebula? Why not more or less than 9 rings? He could not explain the formation of fixed number of planets, 9. It is quite unreasonable to imagine the situation that all matter of one ring could condense into one incandescent gaseous mass to form one planet. According to dynamical theory, the ring may break up into several parts, and thus several planets may be formed due to condensation of small parts. 3. The small degree of cohesion between the particles of the nebula would make the formation of rings a continuous, not an intermittent process, as the theory requires. S. W. Wooldridge and R. S. Morgan, 1959. 4. If the Sun is the remaining nucleus of the nebula as claimed by Laplace, it should have a small bulge around its middle part, equator, which would point out the probable separation of a regular ring from the Sun, but there is no such bulge in the middle part of the Sun. 5. If we accept the tenet of Laplace that the planets were formed from the nebula, then the planets must have been in liquid state in their initial stage. But the planets in liquid state cannot rotate and revolve around the Sun properly because the rotatory motion of different layers of the liquid is not always equal. Only the solid mass of matter has the property to perform rotatory and revolutionary motions along a near circular path without losing its original shape. 6. According to the nebula hypothesis, all the satellites should revolve in the direction of their father planets, but contrary to this, a few satellites of Saturn and Jupiter revolve in the opposite direction of their father planets. 7. About 100 years later from the date of the postulation of Laplace hypothesis, great British physicists James Clerk Maxwell and Sir James Jeans showed that the mass in the rings was not enough to provide gravitational attraction for condensation to form individual pianos. 8. The nebula hypothesis is unable to explain the peculiar distribution of the present-day angular momentum in our solar system. The Sun possesses about 99.9% of the total mass of our solar system, whereas the planets contain only 0.1% of the total mass. As far as the angular momentum, product of mass, angular velocity and the square of the radius of our solar system is concerned, more than 99% is concentrated in the revolving 9 planets, and the remaining 1% is contained by our Sun. According to the law of conservation of angular momentum, the total angular momentum of an isolated system remains constant. Laplace's nebula was also an isolated system. Therefore, it should have conserved its total angular momentum even after the separation of a regular ring, but this is not the case as the Sun contains only 1 or less than 1% of total angular momentum. Thus, this hypothesis is against established mathematical formulation. In fact, the Sun must have acquired most of the angular momentum of our solar system, but this did not happen. Laplace did not explain the causes for this anomaly. It may be concluded that the present-day total angular momentum of our solar system, originally concentrated in the nebula, is not quite sufficient for the separation of ring from the nebula by excessive rotatory motion. Based on above arguments, the nebula hypothesis of Laplace is rendered untenable. Stay tuned for next part. We will cover the dualistic concept of Earth's origin, planetesimal hypothesis of Chamberlain, tidal hypothesis of James Jeans, binary star hypothesis of Russell, and the Big Bang theory.